Cool. Good to have you on, Tillery. Let's just
Thanks, David.
introduce ourselves real quick.
Sure.
Uh,
Absolutely.
so, I'm David Lee. I just volunteer for a cybersecurity nonprofit, and I work primarily as a cyber instructor by day, based for a company out here in Seattle. So, my passion is for letting people know what we do, what security is all about. And to that end, Tillery, I've heard your company is doing some pretty interesting work with malware. I'll let you introduce yourself.
Sure. So my name is Tillery. I work for a company called GRIMM, and I am also in education and training. My career started as a high school math teacher, and I did that just long enough to realize I don't like teaching people who don't want to be in the classroom. So I transitioned from that to my backup. My second major in university was computer science. So I fell back on that, did data science for a while, and kind of fell into cyber network operations programming after that. So I worked for about 10 years as a reverse engineer, focusing on initial access exploitation, and then fell back into kind of this director of training role where I am now. When I came on board at GRIMM, we were doing a couple of trainings, but not too much. And we kind of built that out and have a kind of major training pipeline now that kind of pushes forward a lot of this stuff. So
Wait,
I
go
worked with
back
them,
one
and I
step.
also,
You
sure.
had an amazing job title. Go through that one more time.
Okay, so which one? I kind
The
of rattled through a few
the
there,
one
but
before reverse engineering. That was interesting.
so I was a data scientist and then cyber network operations programmer.
Yeah, cyber network
Okay.
operations programmers. I take it that means you were automating operations. Is that right?
So yeah, CNO is kind of a large field. It's an acronym that kind of originated in the government and military space, and it encompasses kind of it as an acronym. CNO is actually made up of three other ones: CNE, cyber network exploitation; CND, which is defense; and CNA, which is attack. So
Hmm.
most of my time was spent in the exploitation side of things, doing things like reverse engineering and exploitation automation and patching and that sort of thing. So that's also where I kind of found my love of malware reversing and looking at that kind of target. Prior to doing that, I was doing data science work on cyber threat intelligence, and that kind of helped me bridge that gap.
Yeah, I could see that. Yeah, so you've been popping open malware for some time. It sounds
Yeah,
like
yeah. I started
interesting.
out mostly looking at After Effects and things like IPK data, trying to track down where the malware was, where it was acting from kind of a data analysis perspective, and then moved across the pond to kind of do reverse engineering, some on malware, some on just applications, either user mode or kernel applications, and kind of went from there.
So, in order to do that work, I know there's lots of, reading code involved. And did you come into this from a developer background, or you said you messed around with threat intelligence first?
Mhm.
Were there any like code specific skills that you picked up to get
Yeah,
there?
so in university I had a double major in math and computer science. So I'd
Oh,
taken 4 years of computer science training before I did any of that. But my focus in school was on high performance computing and data science. So not anywhere near kind of doing the sort of cyber analysis that I fell into. So I worked a little bit with looking at meteorological research while I was an undergrad, and then when I came out and decided I didn't want to be a math teacher, the first job I got was doing cyber threat intelligence data science. So a lot of the same kind of analysis and like data crunching and number crunching you'd expect from basically a glorified database administrator that knows a lot of math, but applying that to kind of the cyber threat intelligence space. And the thing about that job, I was working for a research company, but we were supporting a SOC. And eventually we got to the point that we had answered the questions that they wanted answered, and we could automate all of those jobs. So it started out really interesting and then became less interesting over time for me as somebody with a kind of analytics mathematics background, and that's when I made that pivot into cyber proper.
fascinating. Wow. So you've done quite a few interesting jobs in your time,
Yeah,
and eventually Grimm happened, right? And this
yeah.
is where I heard of you guys. I saw that you were messing around with Ghidra, and that's something that I teach about only about a day of in my
Okay.
cyber class. Uh, but I think malware reverse engineering is a student favorite topic of ours. It's so interesting, and it's
Okay.
one of those things like when you break it open, it's very obvious that there's a lot more to it. It's one of those things that's like
Yeah.
definitely there's depth there and that you can visibly see.
Mhm.
And so what's Grim been up to in terms of messing around with Ghidra?
Sure. So we don't do a ton of work in the malware space, although we do some.
Hmm.
Mostly most of that works on our federal side. I work primarily on our commercial side for our application security team and our training team. And a lot of the work that we've done with Ghidra specifically, and for example, you reached out to us because of our GearShift project, has been focused on automating these processes of reverse engineering or analysis of some kind of binary. My background is in Windows almost exclusively. The rest of my team is focused mostly on Linux. So they're used to doing reverse engineering or like analysis on pieces of software that you have source code for, right? Because lots of open source projects in Linux. I come from the Windows space where that almost never exists. So we're looking at binaries with no, necessarily no background about what they do or how they operate. Very much like you would see in malware, but kind of for user mode applications that you would just kind of install. And so that's how I got my start in reverse engineering. Actually, was not in malware; it was in typical applications. But in Windows, you have the same problems that you have in malware. With closed source, you just have an executable. You have to find some way to analyze that, and you want to do that in an efficient way, right? So. Malware analysis has its own set of problems, things like packing and obfuscation that you don't see in typical applications. But ultimately, if you could automate those processes, then a lot of that analysis is a lot easier to do as well. And so that's kind of where GearShift came in, and this project that we introduced for Ghidra was we wanted to take some of the painful, difficult pieces and make those easier. Ghidra it's just a reverse engineering disassembly framework, right? It was written by the NSA originally. They declassified it for use by the general public, which was a huge boost to the reverse engineering community, because previously we've been looking at products like IDA Pro, which are thousands of dollars for a license. A little bit after that, Binary Ninja came out, which was in the hundreds of dollars, but that's still, for a hobbyist or a student, a little bit out of reach for a lot of people. So when we have this great open source, Java-based project that anyone can just run, that really pushed a lot of people forward in the general space, and we wanted to tool for that. So when we start looking at the automation we're doing, we want to make that accessible to as many people as possible. We have a whole bunch of open source projects that we work on. Generally, we build a project for ourselves to use internally, and if it looks like it's going to be helpful, we open source it. And this is kind of one of those examples. So we're trying to find a case where, how can we make these things that are difficult for people and for other organizations a little bit easier? So the GearShift project, which is also on our GitHub, has to do with automating fuzzing. Fuzzing is a particular type of attack where you're taking known good inputs, mutating those in some way, and then feeding them into a program to find an edge case or some kind of anomalous condition. And there's been a ton of research for that in open source fuzzing. Things like the American Fuzzy Lot project, for example, which instruments the source code, modifies it so that you know where you are and what input you get. But that's a lot harder to do on the closed source side. Since I come from a Windows background, I wanted to try and make that a little bit better. So this project started as an internal research project. We brought in a couple of our summer interns who had a little bit of a background in some of the technologies that we're using, and kind of had this idea to build it over the course of the summer. And that's where it came from.
Would you, overall for GRIMM, is it more of like a consulting company where you help all kinds of clients, or why is there a research division, and how did that kind of come to be?
Yeah, so we are foundationally a consulting company.
Right.
We are somewhat split between really three major groups within the company. All of us, work together, but we have the federal group, which focuses predominantly on, federal contracting, federal research. Right. We have a cyber physical team, which focuses on things like automotive and aerospace, anything that you have physical hands on. And then we have kind of our commercial and our application security team, which focuses on applications and kind of reversing. So we don't have a research division per se, but anything that we need to do to make our lives easier, that becomes a part of internal research. So we heavily fund internal research to try and make our lives easier. And if it turns out it's going to make someone else's life easier too, then we push it out to the public. Our kind of, we were founded by a bunch of people who left some various other contractors and wanted to kind of have a sandbox to play in and a way to make the world a little bit better outside of the constraints that we had from very large companies. So we kind of came together as a smaller company with this mantra to have fun in our own little sandbox and push the world and make it a little bit better.
So, you were talking about fuzzing, and, my understanding, I'm quite the newbie when it comes to malware reversing, of course. But my understanding is there's, dynamic active analysis, executing a file, and then there's just static, right, of just scanning what the code says, or at least what you've deduced it to be. How does this fuzzing tool fall in Do you have to execute the file, or what does that play out to be?
Sure. So GearShift, this tool in particular, is a static analysis tool. It does
Gotcha.
a series of different static analysis passes, including things like symbolic analysis, where it runs through the disassembled code in not quite an emulator, but it abstracts it out and it does it symbolically without actually executing the program to determine things about how it works. And then that creates a file, which is a C file or a C++ file that you could then compile and run to instrument the actual executable. So the artifact from GearShift would then be used in a dynamic setting, but it itself is a static tool. And it's the problem that it's trying to solve is that when you're fuzzing, you have basically two options. You can run the entire program and hope you get somewhere useful, or you can call into a small section of it and just execute that. But to do that, you have to know that small section. How does it work? What arguments does it expect to have? And that can be a very difficult manual process if you don't have source code to tell you, this is what the function looks like. This is how to give it information. If you don't have that, you need to build that. And that's what GearShift tries to do. It looks at all of the information around a particular address that you say, this is a function that we're interested in calling. And it figures out what the types that are passed into that function would be. So it determines like, this is a structure that was declared in the C code. This is what it would look like. And it creates a C file that you can then compile and run to execute that.
Yeah. So I know reversing is super code intensive. And like you just ran through the core coding concepts of functions and, parameters, arguments, and a lot of those things. It's amazing that if you've never coded, then those concepts are like the hardest because they are what they are. And it's really hard to explain and make an analogy of it. It's kind of like something you just get to know.
Yeah, I mean, we hit the core concepts that, that I taught back in my, programming 101 classes when I was a TA, right? You have variables, which are hard to get your head around, right?
Yeah.
They're stored somewhere, ephemeral over there, right? So you have variables, you have flow control. How does this thing execute? How does it make decisions? And those are hard concepts, like fundamentally, but they're also fundamental to how every program works. So when we're talking about like reverse engineering of malware or of typical applications, the first thing you see is kind of program flow. So I'm actually going to go over here to my whiteboard because I have it. And so when you open a disassembler, for example, and you're analyzing a piece of software, most modern disassemblers give you something that looks kind of like a graph like this, right? Where this is the top of the code execution, and then it makes a decision and goes one of these two directions.
Sure.
And it tries to give that to you in a graphical way. But if you don't wrap your head around the way program flow works or, the way that code execution works, it could be really tough. And behind all of this is a ton of math that does, graph theory analysis to figure out what these edge nodes look like and like edge coloring. So there's a ton of like really cool theory that we don't have to think about because someone smart did it for us.
Yeah. Or you have, power tools that extrapolate a ton of it for you.
Yeah.
And, my students who had a developer background before taking my class were very fascinated by this. And, I think the rest of the folks were just like, that's really cool, but they're still just getting used to like, coding in general. And so I try to save this towards the end of my class where they've been exposed to all this other stuff first. And, it is fascinating to try to actually guess what the source code would be, even though you don't have access to it, but you have access to its behavior. So that's very fascinating to me. And it's cool to see people still actively in this space, because I feel like in the public eye, at least especially among career changers, pen testing is the most popular, one of the most popular like cyber jobs that I think the general public is fascinated by. And it's not every day that I stumble across somebody who's a malware analyst or a reverse engineer. And so I think this is a really interesting field that people really should hear more about, because especially if you have like a CS background, say you did that in college, or maybe you were a programmer for a few years, then this could be like a really fun, like a puzzle solving line of work. Is that what you find it to be?
Yeah. So I one of the things that I found really early on doing reverse engineering was that my C code became much better once I understood what it looked like under the hood. It gets compiled from C to assembly, and that's what is actually executing on the CPU. And once I understood how that process works and what it looks like, and for example, how x86, which is what Intel chips run, how that works, my C code got a lot better because I understood the ways that my code would become the thing that gets executed. So by understanding the underlying mechanisms, I became a better programmer from that. And I think that's valuable for really anyone that's doing, especially low-level programming, but even high-level programming like Java or Python. Understanding kind of the things that sit underneath of that is so important. You mentioned pen testing as well, and there's kind of I have separated in my mind a little bit when I talk to pen testers, because it's not something I do. It's not something I'm very good at.
Right.
But when I talk to people who do it, I kind of see two groups of them. And one is they started with pen testing, and that's what they've always focused on. And then there's the people who have some kind of programming understanding. Either they started in CS or they learned how to program while being a pen tester. And those people tend to get further, because when you're pen testing, you're poking at the perimeter of code running somewhere.
Right.
If that's a network pen test, then you're looking at services that are running on servers somewhere, right? And understanding how code works, understanding how user input gets turned into data transformations, gets used inside of programs, you very quickly get deeper into the problem than you would without that knowledge. When I'm doing web pen test engagements with some folks on my team, I'm blessed to have people who do things that I don't do on the team, which is great, because they can kind of teach me as we're going. But the majority of what we find has to do with things like application programmer interfaces that are just coded poorly. The most common major issue we have is with state attacks, where you're supposed to go 1, 2, 3, but if you just skip the middle step, you can completely bypass things, right?
Really?
And without understanding how programs work and how APIs work, it's difficult to find those sorts of vulnerabilities.
That's one of the top career tips that I heard from among several people in my network is if you're coming in, you want to pick up cloud skills for sure, but also get good at APIs, especially. It seems like APIs as well as containers are security problem areas where they're heavily adopted, but there's not enough testing and scrutiny done. Do you think that's the case?
I agree, especially things that are like legacy. Every organization has some kind of legacy API that was probably written 10 or more years ago that they've just kind of been modifying over time. And there's almost certainly a problem there, right? So that APIs tend to come in there. Things like still seeing ASP.NET services, like we've been seeing in some of the kind of recent things we've been looking at. Those are things that haven't been touched in a decade. Things that have been written recently, if they weren't written with rigor, right, are going to have issues. And one of the fundamental things that we see, and one of the most popular things that I end up training is that development teams aren't taught security in school, or they're not focused on security as they go. So the class that I've taught more than any other over the last 2 years is software development lifecycle from a security perspective. So that comes down to things like threat modeling, understanding what your data actually is, what it's doing, how your application works, and then where does the risk come from? How do we secure that? How do we automate that? And then things like continuous integration, continuous deployment, all of those things help you with security if you know how to use them in a secure way.
Absolutely.
So when I first started, I was teaching things like reverse engineering and vulnerability research or exploitation development. And now I find that the thing I teach the most is going to developers, not to security professionals, and trying to make the developers more secure so that the vulnerabilities are never there to find to begin with.
Interesting. Yeah, I'm seeing the same thing in my teaching as well. Is certifications such as A+, Network Plus, things that were traditionally very just IT ops have now integrated a massive security element to basically all stages of the operations. And it's almost like we have to reteach IT, where instead of it's its isolated thing, it's now something that actually threatens the security of the entire organization if you mess it up, right? So I think that's the lesson that the industry at large, not just security spec folks, are learning is this is something that it kind of goes to the root of your systems, and decisions you make there have major downstream implications. So,
and there's kind of two pieces of that, because I come in as a security person and I sound like a security person, and that's no good if all I'm doing is going in and telling them what they're doing wrong, right? So I focus really heavily in the trainings I do for developers, not on security as a cost center, which is how a lot of developers view it, but rather as security as a way to help them as they move forward. So one of the fundamental things that I teach is threat modeling. Application threat modeling lets you determine if fundamentally your program is secure. Most organizations do that after their code is already written. They have an application. Now let's see if it's secure. That's the wrong time to do it. Now, the best time to plant a tree is 10 years ago. The second best time is now, right? So if you already have an application, do a threat model on it. But if you don't, do a threat model during your development, during your planning phase. Don't write a single line of code until you've already done a threat model. So not only does that give you the opportunity to threat model to determine where risk might come in, but once you start writing code, you know that fundamentally your algorithm or your implementation is going to be secure. So you spend less time rewriting your application after the fact. And that's kind of the industry standard idea that we've seen in security across, especially kind of corporations and financials, is we want to push left as much as we can. The earlier you can do security, the better, because the later you do it, the more you have to fix. And that goes all the way back to the very beginning of your software development lifecycle, when you're still doing, you decide what you want your application to do, you design your application. That's the right time to determine if it's secure.
Yeah, well, it's presumably less costly than a breach later that could potentially just nuke your goodwill of your clientele and, kill your stock investments. And, I always get a kick out of talking about the Equifax breach, because it's just funny how the investors just bailed so fast before announcing it. What was it, like 2 months later, a long time later?
That's a tough one too, because patching is so difficult. One of the largest issues that organizations have is that by the time they know there's a problem, they don't have time to patch, they don't have time to update, or they don't know how. Often security, advisories aren't explicit enough. They don't tell you what good mitigations exist. And when you're talking about, hundreds of nodes, how can you update all of those? Make sure there's no, that updating doesn't break something, fast enough. So one of the things that we've been really trying to do is help organizations figure out these things internally so that they're not blindsided when something happens. So part of that is making sure their developers understand what's happening. Part of that is, analyzing what services do you have running? What's the risk to your application from those services? And that's something that, if I could push one thing out into the world, and I talked to a couple of other folks back in January about this, if I could push one thing out in the world, it's understand what your surface area actually looks like, understand what your environment is, because you can't secure it if you don't know what you have.
Sure. Yeah, that it's good that we're teaching that these days, is that, integrating security instead of just getting alert fatigue from your in-house security analyst going, oh no, you're not patched, is probably the way to go. You had a second thought there?
I'm not sure where I was going. That's all right. It left me immediately.
Well, I'm trying to picture, I come from the IT world, and the thing I always try to remind people, especially people who are like going into security, that they hear this mantra of update everything. The thing that, like you pointed out, I like that you pointed out where it's not always realistic or feasible to just, overnight go ahead and patch all of your systems. I mean, that's obviously the security pro's dream.
Yeah, even if you have the capability to do it, right? You can't, because you need to know that deploying that patch is going to break something else. So you roll it out in kind of an alpha and a beta, and eventually everything's patched, but that could take weeks, right? So there is no overnight patching in a real organization. It can't happen.
Yeah, that's so true. I found that to be 100% the case, or especially if you work with industrial control systems, those things are literally, you're not allowed to patch them, or else they break most of the time, or you lose
those
support.
Things are sensitive to even small amounts of latency on the network can completely break down the way that your operational technology networks work. Our cyber physical team does a lot of work with ICS, and
really,
actually our founder Bryson Bort is one of the founders of the ICS Village nonprofit as well. So
really?
we do a lot of work with them. So yeah, that's a problem really near and dear to me. The work that we've done with US CERT and with CISA kind of like, there's reasons that we focus on helping those organizations out and doing work with them. And it's because these are really hard problems to solve. Even if you can writing the way to do it on a piece of paper, that's not going to help you if you can't actually patch these things, right?
Yeah, and it's like we take for granted because we think we have the solutions. Like air gapping used to be such like, oh, just separate it, you're good. Or and in reality, it's just not that simple. And every time I've given that kind of talk on that topic, people are just, their minds are blown because it seems like that would do it. But then you see things like Stuxnet and it totally wipes out that whole like premise that separating solves the problem. And I agree, ICS is incredibly interesting. I come from that space myself. I spent about 4 years doing systems for a manufacturer. And holy cow, they are hard to secure. Just because if you can't update something, then what do? Try to air gap it? Well, what if you can't afford an intermediary system that grants the luxuries and the access that people want? Then you're in this really tough spot.
We talk about mitigations to issues, and one of them is patching, right? If you can patch, great. But mitigations, they always have to be a balance between security and operations, right?
Yeah.
So even air gapping, right? There's the concept of prevent versus thwart, right? If you prevent something, no one can even attempt to do it. If you thwart something, they try and they fail. Air gapping is prevent, right? If you completely disconnect it, you can't even attempt. But that includes legitimate users.
Right.
If you prevent everyone from doing something, your legitimate users can't do it either. So that means you try and identify and thwart attackers instead, which means that there's the ability for them to attempt an attack. And so you have to find that balance. And it kind of runs the gamut all the way from prevent it, make it not even possible, to detect it, log it, and check those logs every once in a while. Those are kind of your two ends of it, right? Or do nothing, but let's pretend that doesn't exist. So you have detect and log, right? Detect and alert, that's where something like a SOC comes in. You can try and rate limit it, but that only prevents some of the attacks. You can thwart it and you can prevent it. And that's kind of like the different steps in how to mitigate a problem. You have to balance how do you secure something, but not so much that it's completely unusable. And that's a really hard problem.
And that's why I think ICS is like the ultimate puzzle. Like if somebody can solve that, like hats off to them, because it is,
especially when you have all these OT networks that were never intended to be internet connected or really even connected to internal networks just to themselves. But we need to monitor those somehow, right?
Sure.
Even prior to a pandemic where we can't all go work on site, it was still a problem of interconnection. As we start connecting these things to things like smart grids. Smart grids are great. They're really good for efficiency. They're great for a lot of things, but they require you hooking things that weren't intended to be connected to the internet up to the internet. And we have to, that's a hard problem. We have to find ways to solve it.
Yeah, my favorite tool is Shodan to show newcomers if they've never seen that. That's like a big wake-up call. Is to see your backyard on the internet suddenly.
how many cameras can we just find? Or anytime a new an IoT vuln is dropped somewhere, how many of these like smart sprinklers can we connect to on the internet? Oh, thousands of them, all of them in this section of the world. That's not suspicious.
Yeah, that's what makes this field so exciting. Is it really hits home, and a lot of folks that have come to train with me in my classes have personally experienced something like this, maybe a privacy issue or something that drove them to kind of make this their mission. But in your case, it sounds like you took your skills in CS. So you took your coding skills, your knowledge of computer systems, you started trending towards the security world, but then you kind of went, wait a second, I can read all of this, right? So
there are fun puzzles over here that I can try and solve. Let me go do that. That's kind of how I got into it. So because all of my kind of cyber work all started focused on, there's this application, what can I do to it? And I find a lot of people who get into reverse engineering or kind of vulnerability exploitation research and also into malware research started with that kind of puzzle solving mindset. For a lot of them that I talked to, it was they were trying to crack the games that they were playing as kids, right? Either to make them easier or cheat in some way, or just understand how they worked. And by figuring out how this game worked, they understood how computers and programs worked, and they kind of dove into it that way. For me, I came from a okay, so this malware exists. It's cool. How does it work? To how does this network topology work? How did these protocols work? And it's just been a series of puzzles since then.
Yeah, well, let me ask you your opinion then. If I'm practicing with malware at home, well, first there's the challenge of how do I get samples? And I think the answer to that is probably something like hybrid analysis or, known sources for samples. I'd love your thoughts on that, but also testing safely is a tricky proposition. And I usually have folks try to enclose in an isolated, maybe a VM.
Right.
Have you, and I've heard of VM escaping malware as well.
Sure.
What's been your experiences on that? What do you tell people to stay safe when they're messing with fire?
Yeah, so that's a really good question. It depends a lot on what you're looking at. So we'll start with how do you get samples, and there are lots of places online where you can do that. It used to be the only place to get it was on Ware's sites. Luckily, that's no longer the case. So, for example, you can find torrents that are 2 terabytes of just malware samples, and you can just pull those down.
Sure.
There's also a number of VM-like services. You upload a file, it scans it, it determines if it's a vulnerability, if it is malware, based on a bunch of different antivirus signatures.
Right.
And several of theirs also have hosting services where you can download something based on, for example, its file hash. So if you know this particular piece of malware is something I want to look at, you can download that.
Right.
The other place that I typically get it is word of mouth from other researchers. And that takes time. You have to build up and kind of reach out to these people and have an understanding from them. But that's kind of the best way to get it if you want to learn about it, because they're probably researching the same thing and they want to talk to you about it. And that's been really useful to a lot of students that I've taught. So the number one kind of learning resource that I found for that sort of thing is to become a member of the community in some way. And in 2021, the answer to that is Twitter.
Sure.
You go back like 10 years ago, everybody had blogs and everyone was posting on their blogs and you emailed them. Now you tweet at them and they send you stuff and it's really cool. So the number one resource for me to reach out to new security researchers or folks that I know is Twitter almost all the time. So now let's go over to the analysis side of it. If you know you're not looking at something incredibly capable, then having it inside of some kind of container that is password protected so you can't accidentally open it and execute it, that's step one, right? Kind of the industry standard way to do that is to put it in a password protected zip file with a known password, infected or ABC123. It doesn't matter what, as long as you can't just double click on it and execute the thing on your box. That's a bad idea. If you want to be incredibly paranoid, and I know some people who are because they look at very capable, complex things, you have an isolated machine that's just for that. And you reimage it when you're done.
Right.
Most people, and especially students, don't need that. So 90+% of the time, having some kind of virtual machine that you execute inside of, more than enough.
Gotcha.
And that's because you have multiple layers of security there, right? You have to get outside of your virtual machine, first it has to be able to execute and be able to do whatever it needs to do its base level of execution at like user level, right? If you're executing it as a normal user, then it has to privilege escalate to a user that could do something higher, like administrator or system on Windows or root on Linux. Then it has to be able to get something running in the kernel. If you're running as system on Windows or root as Linux, you can do that. You can load modules into the kernel. So then you need some kind of kernel privilege escalation, or to take advantage of something that's already in the kernel and escalate that way. A lot of the exploitation that we see is actually existing vulnerable kernel modules that you just drop and load, especially as we get, that's a sidebar, I'll come back to that. Anyway, once you're doing that, then you have to break out of the virtual machine itself to the virtual machine software or the host. If you're running inside of something like ESXi, which is a type 1 hypervisor, it's running as the main operating system on the computer, then you kind of have a lot more control. If you're running inside of something like VMware or a type 2 hypervisor, which is a software hypervisor, then okay, you've taken over that program. Now you have to get into the operating system of the host, and there's lots of security steps along the way. Sure. So if you're not dealing with something if you don't expect it to be something valuable like that, you're probably safe. I take more precautions because I am a known malware researcher than a student would need to, right? At the same time, no one wants to burn their really expensive, really valuable exploit on some student that accidentally runs it, right? Because if they can analyze it and it can break out of a VM, that means it gets analyzed and we figure out how it did that, we fix it and it never works again, right? When you can sell an exploit like that for potentially millions of dollars, it's unlikely a student is going to have that to analyze.
Gotcha.
Not unheard of, but unlikely. You're not going to be targeted by someone who's using that, and they're not going to burn that and make it unusable for them.
Gotcha. So when you take this, do you recommend that people, if they're going to execute the dang thing, put it in a virtual box or whatever, VMware, and do you recommend they sever the network connection first? Or what are your thoughts on that?
That can be a complex target. So if it's something that doesn't need any kind of network connection whatsoever, and my first attempt is always put it inside of a VM that has no networking whatsoever and see what happens. Right? Sure. If it executes, great, you can analyze it. If it doesn't, because it requires some resource on the internet to exist, then you have to connect it to something. Whether that's the real internet or whether that's a fake internet that gives it responses that it wants to hear. Right. That becomes a harder question. There are luckily utilities that exist for malware research that make those things easier, that will automatically send a network response anytime the malware tries to reach out so that it thinks it's on the internet, for example. Yeah, gotcha. So when we're talking about that kind of tooling, the first place that I would recommend students look is at Cuckoo Sandbox, which is an open source project for malware detonation. That's the entire purpose it exists. It runs a VM that keeps track of everything that happens inside of it, and it does things like handle networking for you. And that way you can try and keep it contained, and kind of see what it does. That works really well for simple targets that don't care where they're executing. But as we get to things that are more and more advanced, they start trying to detect where they're running. Am I running inside of a VM? If so, don't execute, because we don't want them to see what happens. And that's harder, right? So then you have to use different techniques.
So as with most things in security, it depends. And, if you're going to give a blanket general statement to the public, it's going to be on the conservative side of protect your stuff and try to separate it if you don't understand it, and just try to, maybe the better advice is try to understand it before you execute it, I think. Yeah, I will typically do static analysis before I ever do dynamic analysis. The downside there is that takes a lot more time. Doing static analysis is more involved. So, if you want to analyze thousands of samples and see which ones you then need to do a second pass on, it's not practical to do that purely statically. And that's where we get automated systems, which throw it inside of a sandbox of some kind, detonate it. They execute the program, see what happens, and then give you a set of heuristics that say this is likely malware or this is likely not malware based on kind of those processes. And then you can take that second pass and do that static analysis on them. Gotcha. Gosh, I have millions of questions for you. I don't want to keep you all day. I just want to get your thought, with all the popularity of pen testing, what role does malware research play in the macro scheme of things? We have people who are, the big thing these days is like web apps. Are my web apps secure? I need people to test those things. And that's kind of the forefront, I think, of the public dialogue, it seems, or even ICS with that plant and the sodium levels. That's definitely also in the forefront. What's the significance, I guess? What's the impact of malware research as it affects the rest of us? Sure. So there's two pieces of any attack to look at. There's what happens before they're in your system, and there's what happens after they're in your system, right? To the left of the boom, we say is before they get there, before they execute anything. And that's where things like penetration testing and red teaming and that sort of thing, that's where it's focused, is, before they ever get there, how are they getting in? Right. There's an infinite number of ways that someone can attack a system. Our goal is to try and find the kind of low-hanging or most common or most likely methods and protect against those. That's what pen testing and red teaming is all about. Sure. To the right of that is post-breach, right? They've gotten inside in some way. What are they doing next? And typically there's a much smaller subset of things that they're interested in doing. They want to do some kind of data exfiltration. They want to execute in your environment so that they can change the way things work. But that's a small number of things. So malware research focuses to the right of the boom, right? They're in your system, they're trying to do something, they're executing malware.
and understanding how threat actors act, what they're trying to do. That's where malware research comes in. There is a defensive red teaming aspect to that. I always start teaching blue teaming by teaching red teaming. Because if you understand how attacks work and how things like lateral movement work, you can defend against those better. And I think that's a lot of where malware research comes in. Understanding how attackers are going to be acting. And so that's where things like the Metasploit framework, or our sister company Scythe has a post-breach emulation framework. That sort of thing is about helping red teams simulate what malware would do. We can't simulate what malware would do unless we have seen what malware has done. And so a lot of that research kind of comes in there. The other side of that is, okay, you've been attacked, what now? Can we recover from that? Can we get things back? And especially with a lot of attacks ending up with things like ransomware as their final attack vector, where they're just encrypting all of your files. If we can figure out how they did that, if it's vulnerable or weak in some way, we can undo it without having to, for example, pay tens of thousands of dollars. And so understanding how the encryption schemes work can help with that. The way that several, like the WannaCry ransomware attacks, the way that those worked is that they required you to reach out to some site on the internet. And if that site existed, they would not run. It was like a kill switch. So when Marcus was doing the research and figuring out how that works, he determined that and he registered that domain. And so instantly all of that stopped encrypting. Because it reached out to his kill switch and it stopped. And the only way that worked was a malware researcher figuring out how this program works.
Wow. Yeah, that's true. So, I never thought of it that way. Essentially, malware research was like, they basically saved the world from this thing by releasing the kill switch to the public.
And so a lot of that kind of undoing damage or preventing it before it can happen, we have to know how it's going to do that. And a lot of that comes down to reverse engineering.
And my final thought here then is, if I'm somebody with no technical skills, say I come from a totally different industry, what's my first stop? Say like my final destination is malware research or analysis. Okay. What's my first stop? And then what is that like? What's that path look like that I need to walk?
There's a lot of steps, but it starts with having an understanding of how programs work. So my first step in the curriculum that I have that teaches general reverse engineering, not necessarily malware focused, is you need to understand C, because C is very close to assembly. We want to be able to disassemble malware. We need to understand how forward engineering before we can do reverse engineering, right? So first understand some kind of programming language. I teach C. Once you have that, you can start looking at how does that actually work at the assembly level. So I go from C to x86. Ooh. From x86, I go to reverse engineering. And then you're starting to get the basics of forward and reverse engineering of applications. You can see these things that I wrote in my C program, this is what they look like in assembly. So if I start doing reverse engineering on a piece of malware and I see these same patterns, I know what I'm looking at. And then over time, it's just developing those skills and kind of figuring out, like with anything, you do it, you build that up, you learn more. If you're interested in malware in particular, then start looking at malware because it does things differently, right? Normal programs don't try to hide what they're doing. Malware does, right? So start looking at things like crackmes they're written to be obfuscated, to use the same techniques as malware, but specifically not to be malicious, to help teach you those skills. So I'd start looking at things like crackmes and then start looking at kind of low-level malware and talking to other malware researchers. And at that point, you're kind of in it. You're doing it. And you just get better and better over time, like any other, kind of skill or profession.
That's funny. It's almost like, it's kind of like starting the same journey that somebody else would to become something like a web dev, but then like partway in, you like take a veering to the left and go, exactly. Malware.
Instead of thinking about all of these like computer science theory problems that, systems developers are thinking about, I'm going to look at the Lego pieces that go into that. And I don't care about what they're doing. I just care about these little blocks.
How funny. Yeah. Low level computing, it sounds like, is the ticket to really understand this stuff.
Yes, especially when we're talking about things like, desktop malware, something that's executing on my Windows or my Linux box, right? That's going to be running as a user mode application to begin with, probably as assembly. Now, a lot of these things do have their own virtual machines that they run inside of. But those virtual machines themselves eventually gets down to assembly. So if you go deep enough, you know what it is.
How funny. I always love to hear that perspective, the really technical perspective, because I feel like, you know, I've had students even tell me like, gosh, I wonder if cyber is just a bunch of non-technical business people, because sometimes, you know, it sure feels that way with how much compliance that comes into it,
Sure.
how much
Yeah.
GRC. There's a lot of jobs that need filled doing that. And so I think there's an impression that maybe this field is for the non-technical, but it's cool to hear your perspective as somebody who, you know, takes things apart and wants to see what they do at a low level.
One of the things that we put on every job rec that we have for our application security team is that credentialed or degreed candidates do not get preferential treatment. Right.
Yeah.
So because it's about understanding the underlying mechanisms. It's about understanding all the pieces. And yes, you can learn that in school, but you can also learn that from getting hands-on and doing it. And we're going to figure that out a lot better talking to you than we are looking at your certifications.
For sure. Well, I'm glad there's people like yourself out there that are teaching this stuff. Yeah. I can't say I've heard of many malware reverse engineering classes in my time, but I hope those start to spring up. I'm glad you're teaching this stuff. It sounds quite challenging, for sure.
But also a lot of fun. A lot of fun.
As most things like this tend to be, I imagine.
Yeah. The deeper you get, the more focused on the little fiddly bits you get, the more fun you seem to have, even though it's so hyper-focused. So I think that's my career has been built on what's the next cool, fun project I can do. And I just kind of kept pushing it. So.
Well, you know, I have a grocery list in the back of my mind of things I want to ask you, especially like, man, how to get safe samples to test with and to teach others with. But, you know, I'd say that's a wrap. Thank you, Tillery, for stopping by our show here.
Absolutely.
And, you know, how do people reach out to you if they're curious about this kind of work?
Sure. So first of all, thanks for having me. I really appreciate it. You can reach out to me directly on Twitter. So I'm rtillery, ARETILLERY. You can also email me. It's tillery@grimm-co.com or tillery@tillery.fyi if you just want to send something to me. If you want to reach out to GRIMM, you can obviously do that. info@grimmco.com or just reach out to us via the web. But you know, feel free to reach out to me directly if you like.
Awesome. Thanks for being on, Tillery.
Yeah.
And
thank you for having me. I really appreciate it.
Learned a lot about malware reversing and the thought process going into it. So I hope if you're watching, listening, I hope you did too. That's a wrap. Thanks everybody for joining us.
Thanks everyone.